Today we're gonna have a chemical reaction demonstrating the reactivity of the party elements. Those party elements are now hydrogens, 2 plus 2 hydrogens, and plus 2, 4, 2 oxygen, 2 oxygen. That's balance. They will react. Sodium by itself is never found alone. It always combined with something else because it's highly reactive. What do you think I have here?
Brain. A brain.
No way, it's a brain.
That's what I thought it was.
What are we talking about here?
Sodium.
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 Oh,
I thought it was a
Sodium.
brain.
Remember one of the properties of metals in general? They are, in appearance, are they shiny or they are dull?
Shiny.
Shiny. This is not shiny. What is going on? Can somebody explain it?
It's dirty.
Can you cut it?
We cut metal.
Yeah, metals are soft. Oh yes. This group 1.
Dude, I'm
Oh, look how shiny it is! Before,
brain.
look how shiny it is.
Hey, you can see where?
They're very shiny.
Shiny my camera.
Shiny! Shininess! Now it's no longer that shiny because it's being exposed to the air.
Cut it. Maybe because it's seeing Felicia.
I have a nice piece there for the
It's all right.
maybe this is too big of a piece. We don't want to be dangerous.
Yes, we do.
Yes, we want to be
Well,
dangerous.
you guys, but I want to keep your safety and my safety in check. Now you know today why it's that stuff.
Oh, it's gonna make the whole roof come down.
Goggles.
Numb goggles.
We're going in. That's not part of the sound effects I got.
Yay.
Okay, get ready. Here it goes.
It's a big.
It's a fish.
Science in action.
And here we have the equation representing the demonstration, which is on the screen. Sodium in water, a highly exothermic reaction. We need to know how to balance basic chemical equations, and this is a good example. Starting with that demonstration. Sodium metal, we drop it in water, and it produces sodium hydroxide and hydrogen gas. The hydrogen gas, which is highly explosive. The arrow means yields, that the reaction, you have reactants on the left side of the arrow, and it yields a product. And the right side of the arrow, you have the products. So we need to balance this. You have 2 hydrogens plus 1 hydrogen makes it 3, and here we have 2. We need to have the same number of atoms on both sides of the equation. So we're going to use the coefficient here for the water. We're going to use a 2 to make a 4, and we're going to add a coefficient 2 in front of the sodium hydroxide to make 2 hydrogens plus 2 makes 4 hydrogens, and here 2 times 2 makes 4 hydrogens. We have 2 oxygens with the coefficient here, and we have 2 oxygens from the coefficient in the water molecule. We have 2 sodiums though, and on the reactant side we only have 1, so we need to add a coefficient 2 to make it even. So that makes 2 sodiums, 4 hydrogens, 4 hydrogens on the product side, and 2 oxygens and 2 oxygens on both sides of the equations. That makes it even. Next, we're gonna go to a short tutorial. I'm gonna show you how to use the website to practice some basic chemical equations. This is a fan-based learning classic chem balancer website. We're gonna go to practice balancing chemical equations using the reaction in the video, sodium in water, how exothermic it was, and then you saw how we balance it as a chemical equations. This will give you more practice. The object of the objective in balancing chemical equation is that you have to have the same number of atoms on both sides of the equation. On the reactant side here we have iron and sulfur, and then yields, remember that's the arrow, yields, on the right side of the arrow you have the products. So you need to have the same number of them. So it's gonna give you a drop down menu and you're gonna write how many of each you need. So I'm gonna click a 1 for 1 iron, 1 for 1 sulfur, and 1 for iron sulfide, and we're gonna click balance, and it says correct. It tells you also that the iron Fe comes from Latin ferrum, which means iron, and the farrier, which was a blacksmith who put iron shoes on horses. We're gonna do hydrogen plus chlorine gas to form hydrogen chloride, that acid. So here we have 2 hydrogens, but only on the reactant side we have 2 hydrogens, but we only have 1 hydrogen in the hydrochloric acid on the product side. So we're gonna use a 2 here, and we have 2 chlorines, and we have 2 chlorines on the product side in hydrochloric acid. So we're gonna use a coefficient 1 for chlorine gas and a coefficient 1 for hydrogen gas, and we're gonna click balance and see how we do. Correct, hydrochloric acid, the stomach acid that breaks down the food you eat. And I give you a little bit more information on it. We're gonna be working on this, and this next one you're gonna be doing on your own when you work at your lab stations.
We're gonna light up hydrogen. Remember hydrogen, how flammable it was?
Yes.
With the sodium in water? That gas was hydrogen. It light up, right?
Yes.
The sodium in water, hydrogen, same gas. Now I have pure hydrogen there. Okay, you guys ready?
Ready? Yes.
So your flash is off, right?
Ready?
You guys ready?
Ready. Ready. Go. Ready. Your flash is
Oh,
off.
my flash is off.
Okay. Yeah, leave it off. Here we go. Here we go.
It's gonna pop that fast.
Okay.
Oh my god!